All right, welcome to your first video. So in this video, like in all the videos, basically I'm going to go over the topics that we're supposed to be learning this semester. So the way it's mostly going to work is for each day of class, I'm going to post a video. And in fact, usually I'm going to break it down into some smaller parts to make it a little easier to follow and to find things if you need to review. So this first set of videos that you'll need to watch by the next class period has two parts to it. The first part, part A, we're going to learn about the scientific method, what that is. And then in the second video that you'll need to watch by the next class, I'm going to be talking about what an element, compound, and a mixture are. So there'll be two parts. Usually, again, the videos, they'll be broken up into several smaller pieces to make it a little easier to follow. All right, now before I get into any of that about this introduction to chemistry, I want to start off with a little bit just about how to get the most out of these videos. So let me up to a few tips here. So tip number one, this is basically like class, right? This is our class time. So when you are watching these videos, you should be taking notes, right? Get out some paper, get out a pen or a pencil. And that's because you're going to want to be able to go back and review. You're going to have homework on this stuff. We're going to be doing like worksheets on this stuff. So you'll need to be able to, you want to be able to review what we've talked about and have some notes about it. Now, tip number two, in these videos, mostly it's going to be me talking, but every once in a while, like even in just a few minutes, you're going to see that a question will pop up, and you're going to have to answer that question as it comes up. So that answering those questions correctly is going to be part of your grade. And as far as those questions go, if you are a little stumped on them or a little unsure, you could go back and like rewatch the video or part of the video to try to make sure you understand what's going on before you try that question. So in any case, the questions, they're part of your grade, so do your best on them. Hopefully they won't be too bad. All right, last point. You're going to need to keep up with these videos. So when we have our Zoom meetings, I'm basically going to be really counting on you guys and gals out there to have watched the videos in advance so that what we do during the Zoom time will make a little more sense to you. So in our Zoom sessions, yeah, I'll be doing a little more explaining, maybe a few more examples of things that I want you to know about, but we're also going to do some practicing. And if you haven't watched the videos when I'm asked you to, if you get behind in them, it's going to make that practice way more challenging. All right, so do your best to keep up with them. Hopefully it won't be too bad. All right. So with any of this stuff, if you have any trouble as we go through, let me know, and you can email me, you can call me, and I'll try to help you know what you got to do when you got to do it. And if there's any questions on the topics, of course, you can ask those too. All right, so with that, let's go ahead and get started. So in our first video, I'm gonna flip to the next slide here. Oh, flip. We're going to learn a little bit about what chemistry is. So what are we going to be talking about all semester? So chemistry is the study of matter and the changes it undergoes. The study of matter and the changes it undergoes. So we're going to be talking about matter. Well, what the heck is matter? Well, matter is defined as anything around us that has mass. So mass is, it's not exactly the same, but it's basically the same thing as weight. Anything that has mass and occupies space, takes up room. All right, so there's all kinds of matter. Now, some matter that we start off with isn't actually super complicated. Like, for an example, metals. Metals are kind of matter. Like this penny is made out of metal. Do you know what metal is in a penny? What metal is this? Oh, this is copper, right? Copper is what a penny is made out of. So this is a kind of matter. Pennies don't weigh a whole lot, but they weigh something. So they have mass. They take up a little bit of room in my hand. So, you know, that's matter. Has weight and takes up room. So another example would be like just a pen, right? You might be using a pen right now. A pen is matter. This pen is made out of plastic. So it's a kind of matter. It has a little bit of weight again, and it takes up room in your hand when you're using it. So a pen is matter. There can be matter that can be a little bit more complicated, like you have weight, I'm guessing, right? You weigh something, and you take up room in your house, so you're a kind of matter. And then, maybe another example would be, well, sometimes matter, you can't even see it, right? Like air is matter. Air takes up room. It's filling up this entire room, wherever you're at, and it has a little bit of weight, and it's occupying that entire volume of your house, right? So matter is pretty much anything we see around us, even some things we don't see. Now, like air. Now, you also notice another word in here besides matter, and this is the word that actually can make life a little confusing and a little complicated in chemistry. We're not going to just talk about what something is, what is copper, or what is a plastic. We're going to talk about how matter changes, So to understand that, I'm going to show you a little demonstration. Now, if we were meeting in person, often I do this one in class, but I can't really do it in person. So I'm going to show you a little clip of how you can take matter and change it into something different. All right, so let me flip over to another slide, and I'm going to show you that. So I got my phone ready to go. I'm going to play this video in a minute. So let me just tell you what you're going to see. Here in a second, they're going to take a penny, and a penny, remember, we just talked about this, is really a piece of copper. And they're going to react it with some nitric acid. Now, nitric acid, it looks kind of like water. Actually, it's like a clear liquid, but you never want to drink it. It's really dangerous. And they're going to put the two together, and let's go ahead and see what happens when they put the two together. So let me go ahead and play it. Hopefully this will work here, and hopefully you'll be able to see it. There we go. All right, so that's the penny, and it's sitting in a test tube, and they're starting to add the nitric acid. And as soon as they add it, you can see it starts to change. So I know it's changing. I know we're making some new stuff because we see some color changes, right? We see it bubbling. We see it, it actually gets really hot. We see the liquid turning green, and then we see this red gas. This is some red gas forming right here. So based on some experience, I can tell you what those things are. So the red gas is nitrogen dioxide. It's actually, if you've ever been in a smoggy city and you've seen like the red sunset, the red glow in the air, that's nitrogen dioxide. It's the same thing you're seeing right here. The blue liquid is another compound. The blue liquid is called copper, copper hydroxide. All right, so in this experiment, we've created some new things. So that's what chemistry is all about. What are we making, and why did that happen? Why did those two react together? And why did we end up getting a gas, and why did we end up getting like a blue liquid here? Well, that's what we're going to try to work on this semester, understanding how that happens. All right, so with that, let's move on. And in the next slide, I'm going to show you one other thing, or focus on one other thing. And we talked about matter so far, haven't we? We talked about what matter is, anything that has mass and occupies space. We talked about changes. That just means one thing's turning into a new thing. And then I want to work on one last term, which is study. What do we mean by study? How do chemists study? Well, that's going to involve the scientific method. So let me move to the next slide, and I'll adjust my camera so you can see me again. So chemists study using the scientific method, all right, the scientific method. And actually, any kind of scientist uses the scientific method. So the scientific method, it goes way back into the 1600s. This guy right here was sort of credited with coming up with the scientific method. His name was, we'll write it over here maybe. His name was, let's say the scientific method was, we'll say, developed by Anton Lavoisier. And let me make sure I spell his name right. In the 1600s. In the 1600s. So again, there you see a picture of him. He's developing the scientific method. I don't know. To me, it looks like he's kind of focused on something else, but whatever, right? So this is the photo you always see of him. I think that's his wife there. All right. So what is the scientific method? Well, the scientific method has three parts to it. The first part is you ask a question. Second part is, instead of just thinking about the question, you try to figure out the answer to the question. So you do an experiment. And then after you do the experiment, you analyze your results to try to understand what is the answer to that question. All right, so let's do a little example, and let's try to do one relating to that video I just showed you. So let's say I wanted to know, when we do a little experiment like that with the copper and the nitric acid, and this is actually one of the questions Lavoisier was interested in, does the mass, oh, I should point the camera over here just a little bit more. There we go. Does the mass in the beginning of an experiment equal the mass at the end of the experiment? Does the mass in the beginning of an experiment equal the mass at the end of the experiment? All right, so, in other words, if the penny and the nitric acid, I don't know, let's pretend they weighed 5 grams together. When the experiment was over, did the red gas we make and the blue liquid, the stuff we created, did it also weigh 5 grams? So does the weight stay the same, or is it possible the weight would change? All right. So how would you figure that out, right? Well, how would you figure out if the weight was the same in the beginning as at the end of that experiment? Well, the way you would do it is you would do an experiment, and all you would need is a scale, right? You would weigh, that says weigh there, weigh the beginning substances and final substances. So you would weigh that penny of that nitric acid that you use. You'd let the stuff react, turn into that blue liquid and that red gas. And when the reaction was done, you'd weigh it again, and you would see if the weights matched up, right? So, you would, so your analysis would be, trying to see if the weight stayed the same or did it change. All right, and in fact, people have done this since Lavoisier. He was the first guy to do this, actually. And what he discovered way back 400 years ago was that it didn't matter what you used in any experiment, like the one with the penny or the nitric acid, or the one burning something, whatever you do, whenever you do an experiment, the weights stayed the same. The weights did stay the same. I miswrote the word there. Let me erase that. Did stay the same. I'm getting used to this new computer. All right. And in fact, not only is that true with like the penny and the nitric acid, it's true in any experiment. So when we know something and we've tested this idea a bunch of times and it's true kind of generally anywhere, often what we do to talk about what's going on is we call it a law. So this idea, it's called the law of conservation of mass. The law of conservation of mass. So the weight in the beginning and the weight at the end always match up. All right, so with that little example, let's kind of get into a few more terms that have to do with the scientific method. So let me flip over to my last slide on this and get into a little vocabulary you need to be familiar with. Okay, so a little vocabulary I want you to be familiar with for the scientific method. All right, term number one, hypothesis. What's a hypothesis? A hypothesis is a tentative explanation. That's a T there. A tentative explanation for something. So a tentative explanation. Another way of saying that is it's a guess. It's a guess. Okay. Now, when Lavoisier was doing his experiments trying to figure out if the weight changed when you mix things together or when things react with each other, he made a guess. And his guess was that the weight would stay the same. And it turned out his guess was right. So that guess, before he had really tested it or done a bunch of experiments, that's called a hypothesis. So after you make a hypothesis, you test it, you do an experiment, you gather data, you see how things are behaving. And then, depending on how it goes, if things seem to always behaving the same way, that gets turned into a scientific law. So a scientific law is just something that has been proven over and over. Proven over and over. So a couple other things I want to tell you about a scientific law. They're very general. So when Lavoisier was doing his tests, he didn't just test like one thing. He tested a bunch of things, a bunch of different things, and he noticed no matter what happened, any sort of reaction, any sort of process, when he mixed things together, when they turned into new things, always, 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 the weight in the beginning equaled the weight at the end. So always the weight stayed the same. So that's what I mean by general. It's always true. Another thing I'll tell you about a scientific law is it tells you what's going to happen. It tells you what will happen when you do something. Oh, the weight stays the same. And usually, although it doesn't always have to be, usually it's an equation. Usually it's an equation. So an example of that, probably the most famous scientific law, you might have seen this one, E equals mc squared. That's a scientific law. Einstein came up with this idea 100 years ago. It's been proven over and over and over. If it's been proven over and over, it's a scientific law. You know what that law means? Well, the E stands for energy. E is energy, M is mass, and C is the speed of light. So energy and mass are related. The energy is equal to mass times the speed of light squared. So that idea always works. It works in all different situations. Energy and mass are related, and it tells you how they're related to each other. Now, it doesn't exactly tell you why they're related. Like, why is energy and mass related? What does one have to do with the other? Why is E equal to M? Well, if you want to know why they're related, usually there's a theory that might explain why they're related. So a theory is an explanation for a law. It's the explanation for a law. So it explains to you why are energy and mass related? Or like in our chemistry example, why is it that when you do something, the weight in the beginning always matches up with the weight at the end? Why is that? Why are the weights staying the same? Well, the reason why that's true is there's a theory, and that theory is called the atomic theory. The atomic theory tells us that the world is composed of atoms which cannot be created or destroyed. Which cannot be created or destroyed. So the reason why that explains why the weight in the beginning always equals the weight at the end is because if you can't get rid of atoms and you can't make new atoms, if the atoms are going to be there the whole time, the same atoms are going to be there the whole time, they're going to weigh the same amount, right? If we could get rid of atoms, the weight would go down. Or if we could make new atoms, the weight would go up. But if the number of atoms, if the atom stays the same, always, 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 whenever we do any sort of process, not only will the atom stay the same, the weight stays the same. All right, so with that, that's the end of this first video on the scientific method. If any of it didn't make sense, you could watch it again, or feel free to email me or call me. I'm here to help you out. Come by my office hours. I'll help you out. Don't forget, there's another video, another one you got to watch before next class on elements, compounds, and mixtures. So make sure you find that one and watch it as well. All right, good luck. I hope it makes sense. If not, let me know.